Hello everyone. In this video, I solve few more problems related to linear transformation. That means in this case, they had given you a transformation. No general formula for the transformation is given, but where the two vectors go to under that transformation, that is given. You have to find a formula for t of a comma b. That is, here there is a transformation from r square to r square. That is a linear transformation. It is given to you such that 1 comma 1 goes to 1 comma 3 and minus 1 comma 1 goes to 3 comma 1. So using these two vectors mappings, you have to find a formula for t of a comma b, where any vector a comma b of r square goes to after applying the transformation. So there is a proposition actually. If you have a basis v1 comma v2 of r square, and if basis vectors gets mapped to t of v1 equal to w1 and t of v2 equal to w2, two vectors of r square, then there always exists a unique linear transformation t. Okay, if there is a mapping from r square to r square such that it maps the basis vector to some vectors of the other vector space, then you can always find that mapping as a linear transformation, and that mapping is a unique mapping. So let it be. But now here 1 comma 1, look here, minus 1 comma 1, this is a linearly independent set, as well as this spans the whole space r square, means this is a basis of r square. Okay, if it is a basis of r square, every vector of r square is a linear combination of these vectors. So take any vector of r square, it has a comma b. I can write it as a linear combination of 1 comma 1 plus y into minus 1 comma 1. Okay, now I need to get coordinates of a comma b in terms of this basis. So that is x minus y equal to a and x plus y equal to b. So solve this. 2x equal to a plus b, x equal to a plus b by 2, and y equal to x minus a, that is a plus b by 2 minus a, which gives you minus a plus b by 2, because minus 2a plus a is minus a plus b by 2. So you got the coordinates of these vectors. So a comma b in with respect to this basis is called as coordinates of a comma b. Coordinates of a comma b are, so you get a plus b by 2 and minus a plus b by 2. Okay. Now that means a comma b is a plus b by 2 times 1 comma 1 plus b minus a by 2 times minus 1 comma 1. This is how to write a comma b as a linear combination of these basis vectors. Now apply t on both sides. It is a linear transformation. As t is a linear transformation, you know that t of k into v as k into t of v. So this is a constant. Now a plus b by 2 into t of 1 comma 1 plus b minus a by 2 into t of minus 1 comma 1. So I need a formula, general formula for t of a comma b, where any vector a comma b of r square goes under this transformation. A plus b by 2 into, it is given in the question. T of 1 comma 1 is 1 comma 3 plus b minus a by 2 into t of minus 1 comma 1 is 3 comma 1. So this is 3 comma 1. So let us simplify this. A plus b by 2 comma 3a plus 3b by 2, then plus 3b minus 3a by 2 comma b minus a by 2. Just multiply these two coordinates. Now after simplifying, we will get, add these two. A minus 3a minus 2a plus 4b by 2 comma here 3a minus a, 2a plus 4b by 2. So this gives you minus a plus 2b comma this is a plus 2b. So you will get this transformation 2b minus a comma a plus 2b. This is the general formula. So even if you apply now 1 comma 1, where it goes to, you can check. T of 1 comma 1 equal to This is 2 minus 1, 1, and 1 plus 2, that is 3, which is already given in the question. T of 1 comma 1 goes to 1 comma 3. So if any two vectors goes to particular vectors after applying that linear transformation, then you can find where all other vectors go to after applying the transformation. That is a general formula for the transformation that is given like this. Now one more problem related to the same concept. If T is a mapping from R square to R square, which is a linear, such that T of 1 comma 2 goes to 2 comma 3 and T of 0 comma 1 goes to 1 comma 4. You have to find T of 5 comma 6 just for one vector where it goes to. So same as before, you can either get the general formula or just where 5 comma 6 goes to. 5 comma 6 can be written as a linear combination of 1 comma 2 and 0 comma 1, because 1 comma 2 and 0 comma 1 forms a basis, and whenever basis vectors are taken to some other vector, then that mapping is always linear, and such a linear mapping is unique. Now apply T on both sides. That is, before applying T, you have to get the coordinates x plus 0 into y equal to 5 and 2x plus y equal to 6. So x equal to 5, y equal to minus 4. So minus 4. We got 5 comma 6 as 5 times 1 comma 2 minus 4 times 0 comma 1. So coordinates of 5 comma 6 under this basis are 5 comma minus 4. So this apply T on both sides. We'll get 5 into T of 1 comma 2 minus 4 into T of 0 comma 1, because T is linear already given. Where T of 5 comma 6 goes to, where 5 comma 6 goes to after applying the transformation, 5 into T of 1 comma 2 given, that is 2 comma 3 minus 4 into T of 0 comma 1 is given as 1 comma 4. Let us simplify. 5 to the 10 comma 15 minus 4 comma 16. So this gives you 10 minus 4 is 6, 15 minus 16 is minus 1. So this is where the vector 5 comma 6 goes to after applying the transformation. This is how to get the general formula for the transformation when any two vectors of the space gets mapped to the new vectors under the transformation T. I hope you understood the concept. Thank you for watching.